All right, so in all these, we're writing the equation of the parabola. We're writing it in vertex form. So let me put vertex form up here again. If our goal is to put the answer in vertex form, then we need to figure out A, H, and K. Right, because X and Y will stay as part of that form for the equation. If we look at the given information on this first example, we've got a vertex of 2, 1. And we know that this parabola passes through the point 5, 19. So as far as how these values might apply to this form to help us get to this equation we need, the vertex, if that's 2, 1, then we know H is 2 and K is 1. If we know that this curve passes through the point 5, 19, then we've got an X over here we could use, and we got a Y over here we could use. You plug in what you know. Well, replace Y with 19. A we do not know, so A is something we'll need to find. Replace X with 5. Subtracting H, we've designated that as 2. That's all squared. Plus K, well, K is 1. So it looks like we've got one variable left. We've got that variable A. We can solve for that. 19 would equal, this is going to be 3 squared, so that's going to be 9A plus 1. Subtract 1 over, got 18 equals 9A. So A is going to equal 2. We found the one value that we need to ultimately come up with our equation here in vertex form. So our equation for these conditions would be Y equals, following the form up here, A would be 2 times the quantity, X minus H is 2. That quantity is squared. Plus K, well, K is 1. There's your equation that would satisfy these conditions. All right, so same goal, you're writing the equation of the parabola. This time we know X equals -3 is the axis of symmetry for the parabola. And we know that the parabola passes through the point -2, 8. And we're also given on this one that A equals -1. So if we set up our vertex form and we fill in what we know, well, if we know the axis of symmetry is X equals -3, then -3 is the same thing as that H part of our vertex, right? That's the vertical line that's passing through the vertex. H would have to be -3. We've got a point designated here as -2, 8, so we've got an X and a Y to play with. And then obviously we know A equals -1. So plugging in what we know. I'm replacing Y here with 8. A is -1, so I could just make that a negative applied to this quantity. X, well, if I'm using Y as 8, X would be -2. Subtract H. All right, subtracting H. H is -3, so we'll add 3 here. That quantity is squared. And we don't know the Y coordinate of the vertex, so we're just adding on K. The good news is we only have one variable left to solve for, and everything is set up to do so. So calculating what I have inside the parentheses there, well, that's 1 squared, right? So applying this negative, that's going to be -1 plus K. So K, add 1 over, is just going to be 9. To find the equation that satisfies the conditions given here, I'd write Y equals A, which is -1, so apply the negative to the quantity, be X plus 3, since H is -3. That quantity is squared. Adding on K we just found, we'd add on 9. There's your equation. All right, we got one more where we're finding the equation. We have x equals 3 as the axis of symmetry. So I'll go through and I'll label like I did before. If x equals 3, then we know h, as part of our vertex here, is going to be 3. Passes through a couple of points this time, and that's all we're given. So, as we labeled before, if I know it passes through the point 2, 5, then I have an x and a y to play with. But who's to say that if it passes through -1 and -25, I can't use that as my x and my y? Since I have two kind of situations here based on the points, I can set up two kinds of equations. I'm always going back to the foundation here, which is the vertex form, and essentially plugging in what I know. So let's play with this one as we consider the first point. If we just consider the first point, let x be 2, let y be 5. When we plug in, well, we'd have an equation of 5 equals a we don't know times the quantity. Well, it'd be 2 for x minus h. Well, h is 3. That is a quantity squared, plus k we don't know. If I clean that up a little bit, 5 is going to equal 2 minus 3 here, -1 squared, be +1. So 5 is going to equal a plus k. I've got an equation with two variables. Since I have an equation with two variables, I need to build a system so I can solve for those two variables. So now, let's consider that second point that was given. That second point in -1, -25. If I use that as my point and I plug into the same form, well, y would be -25. A, again, we don't know. X would be -1. Subtracting h, which is still 3. That quantity squared plus k that we don't know. If I clean this one up like I did the other one, I find that -25 equals, this would be -4 squared, so 16. Make that 16a plus k. If I sync up these two equations, I can build my system now to solve for a and k. So let's stack these guys. All right, so after you stack the equations, you set up your system, you use any method necessary to solve that system. Elimination would make a lot of sense here. What you could do, you could multiply that second equation by -1. That would just change these signs, right? That would allow you to eliminate these k's as you add through. So adding through, I would have 30 equals, be -15a. Divide both sides by -15, and a equals -2. If a equals -2, what's k going to be? Yeah, it's just going to be 7, right? I can go back up here, plug in that first equation, be pretty convenient. K would be 7. So now we know a, we know k. We had h that was given in that axis of symmetry. If we write out our equation, y would equal -2 times the quantity, x minus h. H again was what? 3. That's all squared. Plus k. K is 7. There's your equation that satisfies those conditions.